Okay.
You videoing it?
No.
The cracks. Did you, no, you did it.
Me.
You put it. You did it.
I'll bang this on YouTube. I'll say hello.
Hey, you want that?
And then there was light.
And there's light. Okay. We have line voltage, brown to black, 229. 229 volts. Black to grey. 229 volts. Brown to grey. 229 volts.
You know, when we're doing this, do you want us to shut it off every time?
Every time we move the leaves.
Yeah, I'm just saving time.
Yeah, no,
really,
I'm just
really,
thinking-
yes, you should do.
Is that what you want us to do? Yeah.
Yeah, you would. There's a lot of switching on and off.
I know it is, but
You do it when you're doing the voltage. When
Yeah.
you're doing the currents, you can just take current
Yeah, yeah,
readings with a thing. But
yeah.
yes, you should turn it off.
Okay.
It's a safe working practice. I'm only doing it to hurry it along.
I just no. I know.
It's a good question.
Yeah.
It's a good question. Okay, that's from me. Okay. Then we're going to take the phase voltages. We're going to measure the phase voltages across each lamp there.
Is there a reason you take it at the lamp and not at the incomer?
Yes, because
Because we do.
what we're doing is measuring the voltage drop across the lamp.
Okay.
So, turn that one on. 132 volts, that's on the brown phase. If we take now the black phase, we've got 132 volts again, and now we can go on the grey phase. That too is 132 volts. If you've got 132 volts, you multiply it by √3, what do you get?
200 and whatever we just had.
Yeah, but the idea is that you do it with √3. How many you got? 132? .732, isn't it?
Yep.
132. 1732. 3 2s is 6, 3 3s is 9, 3 7s is 21, 3 1s is 3, 4 5. 2 2s is 4, 6, 14, 16, 4, 12, 4, 13, 16, 16, 9, 10, 11, 1, 31, 7, 12, 13, 14, 14, 21. 141.62 I've got.
Nope.
What is that?
Calculator is
It's
better.
gone wrong, isn't it?
228.
228?
Yeah.
The pressure that.
I'm on cameras.
You can't perform for the camera, gaffer.
Take 2. 6 3 9 10. 1 11 1 21.
This is going on YouTube.
Sorry, I've got 241, not I've got the other one. 241.
Yep, very similar, yeah?
241.62. I didn't have the one on the bottom. Okay. Mathematically, you'll get a slightly different answer to what you would electrically, but it's very close to it and it should prove the point. Then you've got to take the current readings. Take this one off.
Which line and phase is the same on a star.
On the star, the current in the lines and the phases will be the same. Why is that?
Because it doesn't split, it's got nowhere to split.
Well, it behaves because you have a neutral. It's going to behave as though they're 3 single-phase circuits. So this is the same system as you would get if it was a cable supplying houses, where each load is going to be different. Then the excess, the out of balance current will go down the neutral. With the currents that we've got at the minute, it looked as though, the voltages looked to be the same. the line voltages and the phase voltages all worked out the same. Let's see what the currents are going to do this time. Okay, we're going to go on the brown line, 0.467, black, 0.467, and the grey is 0.464. What should the current in the neutral be?
0.03.
Yes, it should be 3 thousandths. It's reading 4. It's reading 0.004. That's 4 thousandths of an amp.
Yeah, that's close enough.
That one's reading the same, 0.004. We can actually use the milliamp scale because it's so low. We can actually measure this now on milliamps, which we can normally not do. 4.9 milliamps. And this one, .67. It's a slightly different answer, but it's very close. 4.6 on that one. Should be the same on this one. 4.7 milliamps. Okay. What you have to remember with this system is that the voltages will be different, but the currents will be the same. If it's balanced as it is now, we can happily unplug the neutral and take it out the way. There won't be any. What's the neutral current now?
Nothing.
Exactly, there is no neutral. We've measured the line currents. We haven't measured the phase. Did we measure the phase currents?
Do you want us to measure it both even though we know it's the same when we come to test it?
You should do to prove that it is the same.
Okay.
If we take the line current here, 0.468, 469, and we measure the corresponding phase, 0.469, it should be the same. What comes in here, see what comes in here is going through the lamp, across the lamp, and going out on the neutral. When it's connected, that's the circuit. If we disconnect this one, it might vary slightly. That's 0.468. That one's 0.467. What we've got now is we've got no neutral to take that away, so the spare out of balance current is now being juggled around these three. There is no neutral for it to go down. So instead of going down there and being taken away completely, it's been recycled around the lines. So on here, that reads 0 because what comes in goes out. But it may not be that these tie up exactly. These won't be balanced exactly. 0.468, 0.468, 469, 0.464, 465. There should be 0.465. That is. So, yeah, it holds up that the phase currents are the same, but now any out of balance is shared around, and it just won't go down the neutral. It'll be handled by the system, which is really a smart bit of science, isn't it?
Lovely old job.
What we're going to do now is change this lamp. We could change any one, it doesn't matter which one you change. This will put the system out of balance. What will the result be as regarding the line currents?
This is a
lower wattage.
They'll be out of balance and they'll be sent back down the neutral.
So they'll be out of balance.
You'll be drawing less on the middle phase.
The middle phase, which we'll call the black line, will carry a lower current because the wattage will demand a lower current. So this one is 0.468 again. This one is now 0.308. And that one is 0.464. So the other two remain the same.
So 1.6 you should have.
So what we've got, what's the difference between
1.6, isn't it?
308 as against 469?
1.61.
308, 161? It's 158.158. Well, that adjustment can be for the instrument, whatever, but that's where the imbalance goes. It's the difference between what this one can cancel out on the other two and what's out of balance going down there.
We got to do this, haven't we?
Yes, but you've got all the paperwork all lined up and it's got all the relevant boxes to fill in. And when you kept with the unbalanced system like this, again you can take the line currents, the phase currents, you take the line voltages and the phase voltages again, they may ask for it, but they'll certainly ask you for a line current, for a neutral current, sorry. For a neutral current, so you just write down the neutral current and then prove by subtraction that that is the remainder of the out of balance current. The out of balance current, or what this is pulling, will cancel out on the other two lines, but what's left, what isn't cancelled out, goes down there. All right.
Lovely.
Okay? The delta system, that